to be fairly simple, but you never know what happens. What about Wikia? Wikia hosts 150,000 wikis. We run on Mediawiki. We're founded by the same people as they founded Wikipedia. 5 million content articles, 28 million or so pages in total, 950 million page views, and a fair amount of unique users across the world. So we run Mediawiki. It's a legacy code base. It's very legacy. It's 10 years old now. So unlike most web shops and other places that work where we control the entire stack, we don't. We have to kind of treat it as something that we can change a little, but not very much. And these are examples of wikis that we host. Wiki being, in my opinion, the world's second largest wiki of Wikipedia. And then Muppet, Trueblood, and Stork, Wikipedia. So most likely you come across us without really realizing that you are a Wikia site, especially if you take you in any form or fashion. From an operations point of view, we have around 1,000 cores that run the site in total. We have 5 data centers, 3 in the hubs. 3 ops guys in Poland, and 1 ops person in the US. And then the sits down at 3.5. And we push a peak around 3 gigabits per second throughout the different data centers. They peak at different times, but this is a global peak. So I'm going to start talking a little bit about metrics. JJ is a good friend who works at Amazon, who's not here. But whenever I give a talk, he always heckles me because I give out a lot of numbers without necessarily saying where those numbers come from, or he thinks they are just quoting. So I'm just going to go through the 4 of the different, or actually go through 2 of the different ones we collect. One of them is a pretty neat pack. Because we love metrics in Wikia, we're also very, very cheap. If you ever deal with us, you will come to realize that. So we don't really want to store raw quantities of data. We try to avoid it as much as possible. So we have to use Google Analytics. If you actually look at the Wikia page, on some pages I think we called Google Analytics 14 times. So I suspect we are sending Google Analytics on the order of 10, 11 billion impressions a month for different reasons. So this is basically how we collect end user performance. We do that at 7 points, but this one is particularly when all the content has loaded, but images might still be loading and ads are not yet loaded. That's the number I'm going to focus. So at the top of the page, we save the date, and at the bottom of the page, we make the URL. Lean Monaco is the name of the skin. We have multiple skins. So we put the skin in there, and then we put the second, and then slash, and then subsecond. And then we feed that into GA. And we actually, it's not on here, but we also set the title to the URL, so we can kind of use that as well. This runs on every single page that we give us. So on around 30 million pages a day, we collect this data. So here's the distribution. We go into GA and you type, we go and look. And this is sorted by seconds. So some things load faster than 0.1. Then it's bucket 0, 1, 2, 3, 4. And if you look at exit rates, it's pretty spectacular. Right? At less than a second, less than 0.1 seconds, it's 9% exit rate. And at 0.7, it's a 17% exit rate. That doubles the chance that the user leaves your site. Now, there's a control that should be done against this, which is it should actually discard anyone who only sends 1 page view, because that is should be, and I have numbers that tracks that separately because the first page view is cached. So they will, the bounce rate is higher, it will be lower. Here's a graph that shows the exit rate. So if you ever need like argument for why you should make your site faster, this graph is a pretty good one. Here's the distribution of load time across all of Wikia. So using GA, you can go in and basically get to the data great tool if you don't want to invest in your own data warehousing and reporting and collection and load aggregation and everything that comes along with that. So here is the California distribution versus Brazil. We have a data center in California. We don't have a data center in Brazil. There's a pretty dramatic difference in the page load times. Here is browsers collected in the real world. You can pretty much see the performance difference between IE, Chrome, Firefox, and Safari. IE being the slowest. And I don't really know if Safari or Chrome or Firefox is, but if you can actually go and get the numbers and do the math. But there's certainly a distinct speed difference. So, you can get for temporary browser, ISP, mobile device, iPhone touches are faster than iPhones. Sorry, iPhone touches are faster than iPhones. Most likely because they're coming from Wi-Fi and not 3G. I looked up Verizon versus AT&T a while ago, but there wasn't really much meaningful data because there weren't enough Verizon devices that have JavaScript enabled. So really didn't get much, but you can for free dig in and get all these numbers. So I can highly recommend that if you use analytics, or even if you don't use it, just throw this on your page list and go for it. Do it in a different profile so you don't mess up your main data source. We also do this with errors. So we were having a lot of random errors on site that we couldn't really track down, we couldn't really figure out where they were happening. And because we have different data centers, depending on which data center you hit, you might get a different error. So we started tracking every single error of the analytics using this. This is BCL. So especially Varnish error we visit, but we also put it into the code that emits errors for the app. And you just call it, we include both the URL, the identity, the error message, and which backend was throwing. And then we get this. This is year to date. All the errors that have been served on Wikia, where a user got an error page. So 1.1 million errors. Most of them, apparently, this had to do with LVS, which we then got rid of. And then, here. Yeah, the London Varnish has more errors than the others. I don't know why, but so this is pretty neat. Again, collection for free, and this is errors that users actually see. And no server-side collection, no log analysis, nothing. So we also use Penguin. It's kind of boring. This is, if you ping wikia.com, which is load balanced across the internet, we've had 2 minutes of downtime since the beginning of the year. We also have an average latency to wikia.com from Penguin's network of 24 milliseconds right now. So pretty good amount of coverage with only 5 minutes. Health check, not so good. 42 minutes down. I believe we still need Facebook. But we're working on fixing this. So this is time the user might get an error or time the user might not actually get any response at all. But all in all, that's led us to these uptime numbers year to date. And we're very operations-driven engineering. There are, well, I kind of join all sorts of internal teams all the time, trying to instill that you have to make sure your code works. People in the dev environment are on call. They're there when things go live. We review all the queries, etc., but we always try to think how a certain piece of code will act in the live environment. We are geographically distributed, which has saved us a bunch of times. We have 5 locations and 6 different ISPs plus peering agreements. We tend to fail fast. Like whenever we do code pushes, we look at the errors, and errors we reverse prior to these. And in our main data centers, everything is redundant, either on the infrastructure level or on the level of the code you use it. So we have we have a double network with bundled servers at the bottom and then all the way up through the stack. But really, what allows us to have this kind of thing is magic in a box. So this is 2 servers that I flew with as checked luggage to London. It's our London data center. I couldn't find a picture of the recent trip I did, which was to Frankfurt. That was only 1 server that I checked this luggage. Turns out that buying servers in Europe, if you don't have a European presence, is very hard. VAT and so on. And then shipping them is even harder because of customs and stuff. So check it and walk over the border. And the airline has no problem with it whatsoever. TSA will search it completely, and then leave a little sticker inside saying they've opened it. But it still works. So. And these run Varnish. So who here uses Varnish? A fair amount. If you do HTTP, the rest of you basically should use it. It's fucking awesome. And it's so Wikia has an interesting position compared to a lot of places which we don't use cloud service providers. Not strictly true. We use it for things like the Ops IRC server, the Ops monitoring server, and so on. But we find that every time we try, it's fucking expensive and it's too slow and it's too unpredictable on the response rates. So, and internally, we do use virtualization, but no request that serves an end user will go through any virtualized service. Going back to the keynote this morning about latency, virtualized servers introduce unpredictable latency at usually the worst time. So, if you can spec your hardware to your app and write your app to the hardware, you're way better off than on a cloud provider or on a provider. Right? Modern hardware is freaking amazing, and especially if you throw these in. How many people use SSDs? You're missing out. How many people have SSD in your laptop? Okay, that's a bit dark. My Mac doesn't even show a boot per waypoint. It just boots. Right? And I hear sometimes when people say that SSDs don't actually save power. That's fucking bullshit. Because they feel like 0.8 watts versus 15 watts or 15 RPM drive. But you also need way less of that. So instead of like 15 RPM drives, you need like 2 SSDs to get the same IOPS. Actually, the SSDs can probably still keep the drives IOPS by far. So you end up saving a lot of power in the data center, more so than laptops that take down all the time, you know, 5,400 RPM drives. So even our Apaches now have SSDs. We get a 40 gig SSD from Intel, we put it in there, and guess what? We can now run with swap, and if the machine starts swapping, it doesn't die. Because Linux, however bad the swapping implementation is, will still want to kill the SSD. And the OM killer never kills it. Our Varnish machines, which is also the same for database as SKU, it is a X567 CPU, 12 cores, and then Intel X25, 160 gig SSDs. And it's important to note that no RAID card we have ever tested can keep up with an SSD. They will do the transfer rate, but they won't do the IOPS. And they will reach a point where you saturate the RAID card CPU, and the machines will basically stop working. Right? Game on. Oh, by the way, if anyone has questions, then feel free to just raise your hand. I'll answer. So connect them directly to the operator software to the motherboard, and you will get amazing performance. And this machine uses 350 watts. Its max power core is 500. It uses, for us in production, it uses around 350. Right? Yeah. On Varnish machines, we use no RAID. We just use multiple JBOD. And on the database servers, we used to use RAID 10, and it was so ridiculously fast that we're now starting to experiment with RAID 5 to see if our RAID 6 are different one, to see if it actually will have problems. Yeah?
So SSDs being new enough, What do you know about failure modes? Do they degrade as they're failing? Do they instantly fail? Can you tell it's coming?
So the first batch of SSDs we got from Intel had a 25% controller failure rate, which is pretty bad. But initially we only used them in caches, and we're like, you know what, if they fail, what the hell? The latest Gen 2, we not really have much degradation problems. With the Varnish caches, we have a little bit where we need to secure erase them, because the write pattern is pretty bad. On the databases, we never delete data, we just add to them, but we've seen no degradation whatsoever. And, you know, if they fail after 3 years, well, I don't trust them from the hardware after 3 years either. So we haven't seen, the last 12 months, we haven't seen any problem with them apart from the normal failure rate we've seen in hardware. Yeah, I think even less actually. So there have been cases where they degraded really, really badly. We've seen extremely bad I/O latency, but that hasn't happened, I think, since the beginning of the year. Yeah.
In another session, they suggested that certain SSDs were better reads, others were better writes, and none really do both well. Have you had any? What's your experience?
We've tried a lot of different SSDs. It's been around years since we did our last shootout. The Intels, as far as we are concerned, are the best price performance. I have performance numbers a bit later, but they're freaking fast and they kind of do both. So I'm really looking forward to the 300 gig and 600 gig SSDs coming out, because for the first time in my life, I have database servers who are not IO bound, and they're not CPU bound or memory bound. It's just we need more space for the SSDs in them. So when they come out, we'll just buy way more. So this Varnish machine, using browser mode, it did 106,000 HTTP requests per second, fetching a 1x1 pixel image. And ignore the top curve, that's a buggy browser mode. Look at the bottom one. The blue one is to connect the first request, and the other one is the subsequent request. This is 10 requests per connection, which is higher than Wikia runs in production. I think we got like 5 on average, but and this was using like less than 30% of the CPU. I did some bottleneck somewhere, probably in the network, but you can easily saturate the 10 GB image on one of these machines, and the response time stays pretty static. Now, a little sidetrack here. I keep hearing that people use Mysql or abandon MySQL or write really stupid tables because you can't do joins. Really, put an SSD in there and then get over yourself. Because the problem with joins is non-locality of disk. Guess what? If you have 500 megabytes per second of random reads with a 0.1 millisecond latency, your locality doesn't really matter. It does a touch bit, but it's like, really? So, to speed, yes, there's a difference, but 220 megabytes per second of random writes and 500 megabytes per random read for a $2,000 subsystem is like, I mean, it's what I call those fans for $2 million 5 years ago. So this you should be using them in this direction. Like they completely change how you can model data, how you can access data, how you can store it. Like it's basically like having tons and tons of slightly slower RAM. And it's interesting to code to as well, because a lot of things you do that we've done traditionally when we write code assumes slow disk, assumes slow commits, or slow fsyncs and so on. And we don't really have that with SSDs, so we can access the data in different ways. Like mem-mapping suddenly becomes much more convenient when you have them underneath. We run something called semantic Mediawiki, which is a huge pile of SQL queries doing RDM store with like 7 nested joins, and they would very rarely kill our normal databases. With one of these database servers, they just went away. Right? It just doesn't. And I think we replaced 7 disk-based database systems with one of these. Right? So yeah, they use the power times a ton. So Wikia built our own CDN. We use sign into our DNS, we build DNS, and we build these cache hubs. And the reason why is because no CDN provider does instant purging. There's 2 minutes, 5 minutes, somewhere in between. But no one will go, oh, here's a purge, go purge it, and it's gone. And that's vital for our versions. And the other is it's so cheap. And we can take a $5,000 machine, jam it into vkits in Frankfurt, in the Internet Exchange itself, and just serve traffic. So each of these nodes runs Varnish, Wikia, and Bind. So they actually pretend to be BGP routers. So the one in vkits, for everyone else in there, is a BGP router to the VK network. For us, it's a BGP router that serves traffic. And we peer, I think, 35-40% of our traffic in Europe now is peer, for free over the especially Middle Eastern and Eastern European ISPs really want to peer across because it saves them more money than it saves us. Yeah?
Why was a few minutes too slow for video?
Second?
Why was a few minutes too slow for video?
So when you edit a page, that page needs to be updated for everyone immediately. So take, for example, in Wikipedia land, the Michael Jackson died, people edited the page continuously. Getting an update 5 minutes later is not very useful. For us, like during the lost finale, that page was edited every 4 seconds or something. So a couple of minutes delay is just too much for us. So yeah. The other one is fine-grained control. I'll go over some of the DCL later, but we do a lot of inspection of cookies and other fine-grained control that we couldn't really get from a CDN without paying a lot for integration services. We still use Akamai for our non-dynamic content, so all the images and so on go for Akamai, but they pull from our CDN. So we actually peer with them as well, which saves a bunch of money. So, like, most dynamic content, unless it's heavily personalized, is cacheable, right? You just don't think of it that way. But you can usually cache it for a few seconds. And once you cache it for a few seconds, your backend is kind of safe, right? Twitter uses Varnish for search to Twitter comment. It's a perfect application where, in normal cases, your hit ratio is basically 0, and then something happens, and everyone searches for the same thing, and now your hit ratio skyrockets. And it protects you, like 1 second TTL, 1 request to backend per second, versus n number of requests to backend. So it really helps you with those spikes. This is the lost season finale, or actually, I guess, complete finale. And you know, having our own CDN really helps in this situation. We don't even see those spikes. And even if you have, you know, mostly logging users, if you are afraid of low spikes, most of those low spikes are not going to be users that are already registered. Like you're going to be hitting your sign-up page. Nothing catch that shit. And it also, you know, someone tries to DOS us. It's usually script kiddies. We don't really know. Like just silk up. I'm sure that if someone like real tries to DOS us, we would notice. Because we don't have more than 4 gigabits of bandwidth, but for most requests, like, we don't care. So then we've done some magic. It gets kind of complex. Yeah.
Is this
Where?
the Q packet that they say,
Quagga?
Is this how many layers?
It kind of is actually because we use Quagga for OSPF as well. But this is pure Varnish context, where, so if I'm Frankfurt, I'll try London. If London is down, I'll try Iowa. If Iowa is down, I'll try San Jose. If I'm London, I'll try Iowa and then San Jose. If I'm Iowa, I'll try San Jose. If they're down, I'll try my own local backup bits. So, and then, if everything is down, I'm just going to serve a stale request. So we have situations where we've been down for like 10, 15 minutes on the back end, and most users never notice because they hit cache content, right? And even cache content that we can only cache for a very short time, if the back end is down, we serve the same. Better than not serving it at all. So, yeah, it's basically one way to achieve to get the availability we do. We also have multiple types of data centers. We have the master data center, backup data center, which is also master capable. We have a rendering class data center, which we actually don't have in production right now. We're building one. And then we have caching data centers. Our backup data center is in a nuclear bunker in the middle of Iowa. I feel very safe when I go there. I also feel very deprived of light and human contact and good food. So that's the downside of that. The plus side is 90 amps of 2 per rack, which is pretty fucking amazing. And we have our Gambia installed for Iowa is actually public. So you can go and see there. We're about to put all of our other Gambia installs public as well. This is very appreciated by our users because they go there and look and see how the site is performing. And then they ping when they're seeing tell me that the service version. Crowdsource monitoring is also. We have a constant race between our monitoring systems and the IRC server, the IRC channel, Wikia and Freenode, on who detects outages first. And mostly it's the users. And they have like a secret bat signal they plug in, which helps people all have their IRC clients listening to. And then we can go help them. So it's extremely useful when the CDN breaks or Akamai breaks and they're in somewhere we are not.
Are you doing wildcard evaluation?
Wildcard evaluation? No. We don't because we do too many validations, so it overloads the wildcard ban purging mechanism. So we do precise validations. But we do a trick that allows us to canonize the URL and purge over variants from object movement. So that's all I get through soon. So right now we have automatic failover. The main data center goes down, it fails over to Iowa, which is in read only. This works pretty well. We've tried it multiple ways and keeps the site up, but people don't do any of it. The problem with it is expensive. You get that twice as much hardware, and users don't see any benefit in normal versions. So we want to move to active. Sniffing a cookie to see where you should be going. Like if you just make an edit, we will send you to the master data center because then we don't risk temporary lag thinking we don't see it. Otherwise we send it to the closest. And now what we actually want to go to is active. Because we want to build 5 kilowatt, 7 kilowatt pops that render the site as close to the edge as possible and then build 4 or 5 of them. So then we can drive down the overhead needed per pop because we calculated only lose 1 out of 5 or 2 out of 5 instead of 1 out of 2. And users get happier. Also, it's a very good leverage when negotiating with your hosting provider. Oh, you want to charge me more? I'll just shut this site down. And it's not really a problem because I have like 4 other sites. I'll just take the load and just move my server. So you really have no leverage. Versus, this is my only PC and you want to charge more money? Like, I do. The problems we encounter is Memcache synchronization, session synchronization, file synchronization. For Memcache, we're just playing around, trying, using, none of this is fully production yet, but the Facebook technique that is injected in MySQL, the Memcache release into MySQL application script. It's a previous attempt at keeping those instant is pretty hard. Our initial approach was to send the validations over rapid, with the mouse in low position, and then have the daemon wait. And that was just a mess. So this looks pretty promising. And then we're using Riak, which was there talk earlier about Riak? It's a key value store, has an HTTP interface, which is actually really nice because I never want to deal with crypting, which is a piece of shit. I especially like when I'm trying to find out what's in code house, and I correct for it, and then I get like the Ruby version, the Python version, the Perl version, the same names, all looking like crap. And the identical binding. Yay, the code generation. And key for us is that it does end-master inter-DC replication using this vector folks.
What properties are you using? What are you using for?
I'll get there. So if you look at this here, session synchronization, file synchronization. So end-master inter-DC replication, nothing else we looked at could do this in the same fashion. So first, we're using it for Riak for files. We're working with something called Riak.fs. It's on GitHub. That's a very experimental. It keeps changing, and I haven't pushed the latest version for a while. It's a fused layer for Riak. Stores files on the Riak cluster. Uses a separate bucket for metadata. So here we keep metadata on SSDs and the large files on large disks. So it's very, very fast to move around. And the seek times for doing stat or LS is really fast. And this is because Mediawiki assumes the file system. There is an abstraction, but we run 300, 400 extensions that are written by users that don't actually know what they're doing. So they will use the file system. So we need to emulate the file system. But then we can serve files directly from Riak to Varnish. So we don't need to go through the POSIX simulation layer. Instead we go through this, which just translates the URL into something that Riak.fs can read and search it straight out of the file. Riak.fs uses vector clocks to detect conflicts in metadata, so it is safe to use, and it's safe to use between multiple data centers. For the file itself, lost file wins. POSIX doesn't really give me much choice on that to expose any errors or so on that. And soon we will support Riak's new large file mode, which will make it distinctly more useful for files larger than, I don't know, a couple of megabytes. And it's very experimental right now. We've written large amounts of stuff in it, but I don't think we're putting it in production for another month or two, maybe probably January 1st. We want to hit the December deadline. The other one is sessions. We use it for sessions because people fail over and they don't have a session and there's something logged out and they click somewhere and they fail, we recover and they fail back and they're not logged in and they get very confused and upset and shout at us. So we need to keep the sessions in sync between all the data centers. That's where the end-master replication comes in. So we're using Riak as a session store. We're also using it as a blob store. Mediawiki stores gzipped full text of each revision. We have, I think, 125, 140 million of these. They are stored in one Mysql table, which is very unwieldy. I think last time someone did a full table scan, it took close to a day. So we're moving that into Riak. So we can, so all of this is a key value. So active, as opposed to the target is January. We don't do any changes after December 5th. I don't really think we're going to be ready, but beginning of January we're doing it and we're building a node here on the East Coast. So the route requests. We have VPN tunnels between all the data centers. We looked at getting dedicated types, but the cost of transit is declining very, very rapidly. So VPN tunnels for now seem to be working well. We have a mesh option between all data centers. We use OSPF, and we set the OSPF cost to the latest between the data centers. This results that sometimes Frankfurt to San Jose goes by London and saves 10 milliseconds over going over the public internet. So this is how Akamai routes cost as an internet. And it works really, really well. The area 0 is all the VPN links, and then each data center has its own area. And then we use Varnish. So even, as I said earlier, things are cacheable. But even things that aren't cacheable will get a speed up. Like we send non-cacheable stuff through Varnish all the time. In fact, Varnish is the only way to get into the data center. And that's because of syntax. So this is, if you're doing a 1x1 pixel, this is what happens. Syn, act, request, response. From Europe, 400 milliseconds before you have This is what happens when you have a CDN that's clever. Wow, you just shaved 170 milliseconds on that request by keeping persistent connections. Or, and the large things, which I don't really have numbers on, but you avoid slow start. So, you can only send 2 packets in the first response, which most large websites seem to ignore these days, and send like 5 or 6 or 10. That might be a tweak when it do Linux kernel. But with like that slow start only hits on the last node because you have a persistent connection running to your backups. So Varnish uses configuration language VCL, and it's pretty expressive. We have 3,500 lines of statements across 6,000 lines of config, which is essentially is code. And it gets converted into C code, and the execution path is written, which means you can embed C code, which is very, very useful. So when we purge, we send the URL of the purge over scribe. We used to use Rabbit, but it tended to die randomly, so we switched. That URL then purges all variant size. What we do is we take the URL, we store it in a header, and then we rewrite the real URL to be index of PHP title equals and canonical. Because people can request that /wiki/Swedish chat, or index of PHP title equals Swedish chat, or that action equals role, or action equals render, or force profile equals 1, which will show our internal profiling, or force trace equals 1, which you can do in Wikipedia as well, and you'll see the entire execution path of the request. Very handy for debugging. So we categorize that down into one request. And then we set the vary of the object to include X or URL. And then, when we send it to the backend, we restore the URL on the backend request. So the backend sees the request exactly as it was requested. It's just not cached on that. And that means that when we purge an object, you actually purge all variants of it. We do it for thumbnails as well. Like we store the size of the thumbnail in a separate header that we vary on, and then we purge the image, and all the thumbnails get purged at the same time. The important part is to set the variant, and then ideally kill the variant before you send it out to the client so they don't get confused. And then the purging itself, this is in line C code because Varnish 213 doesn't actually have DCL to do it, but in this function there, where all we do is we call VRT purge, and it kills all the variants. Another useful thing we do with Varnish is loop detection. So all these Varnishes sometimes take a life of their own, and I've seen cases where requests have been forwarded 20 times between different Varnish nodes before they actually eventually reach a backend. And unless it's between the data centers, it's so fast you don't notice. But we implemented loop detection to get rid of that, which again is inline C code. This means inline C code. So all this does is it takes the identity, it checks if it exists, and if it exists, it throws an error. And if you pass, it sets the X forwarded from header, which is different than the X forwarded for header, which we also set to include identity. And then in DCL error, if we see the status code, we set the detected and send a reply, and then the reply will cascade back through the system, which has status code. We do geo-targeting. You set a cookie that looks like this, set from inside Varnish, using the maximized GIP library. So it's cookie is set. We do a bit of C code that creates a JSON object that it puts inside the cookie, and now we can use JavaScript on the client, even if the user doesn't have HTML5 application support, to target ads or don't show things to British users because of title reasons and stuff like that. So again, exposed by the fact that it isn't Betsy coded. Same for A/B testing. This is static. It's hard to A/B test, except we can use this to cookie users and choose different response request styles. So this was a test we did where we tagged 100,000 users and a control group of 100,000 users during a 24-hour window, and then we are tracking them for various reasons for 30 days. So at the edge, very, very fast, and your backend servers don't need to think about it. We also add this to every request, so we can add debugging, helps a lot with end users, because they can just use header spy or something, hoping they header and see what's going wrong. So that's the VCL for that. I think that should be standard, but it isn't. We also have a couple of special pages where users can choose that they want to be a data user or a trunk user. And if they're a trunk user, they will get a server in production that runs trunk. And if they data, they'll hit one that's about to live, or they can choose to hit a specific data center. We do that using this. So we look at a cookie, and we choose backend based on the cookie. So that's pretty useful. This is the restart logic, where if it's this backend and it's down, then choose this, or that, or that. Again, this I think saves us so often in the window of errors. We don't do restarts from post, but we do it for all hits. So any backend commits an error, we will be trying to another data set. So that works surprisingly really well. We've had some situations where they were no backup and they just retried the same server, we had overload. That'll do with Kubernetes, but those misconfigurations. We also do mobile phone detection at the edge. So if any of these things are true, we have use skin equals Wikia phone to the end, which any user can do. And now they get a full experience. And then it gets hashed in the URL. So it's still cached, but it doesn't conflict with the main cache. And because we normalize the URL, all of this will get purged in one go as well. And then the actual request sequence is like this basically. This data center do this, this data center do this. The if server.ap equals is an ACL check. There's a side effect of Varnish letting you do ACLs on your own server. We try very hard to only have one Varnish config that does the right thing depending on which server it is on, because otherwise it gets kind of, it's easy to make mistakes when you load the wrong Varnish config on the wrong server and things start going wrong. So we don't auto-generate the configs. We auto-generate the backend definitions, but all the logic is not, and it uses code inside to determine what to do. And that just continues onward. And here's more of the request stuff. So I think I have 5 minutes left for questions or something. Go.
Purging, or Memcache.
Yeah.
Some question about that. So, you said it's not in production yet, but.
It's not live. We test it in production tomorrow.
Okay. So that makes sense. You have a slate that has the black hole storage engine?
The master has a black hole. The master has a black hole engine, but it still replicates the statements. And then you just restore the bit log on the slave, then you table that file.
So that's what I was wondering. So you wrote something to essentially Mysql inlog follow?
Yeah.
Inlog?
I believe you use map kit one or something.
Okay. Cool.
And we have those logs on our data center anyway because of the free nature of our kit.
What's the learning curve like on VCL? You were pretty hard line into it. Was it trivial at some point?
Well, I contributed to the core, so that makes it kind of easier. I think that if you understand HTTP caching, it's not that hard. However, it is pretty easy to get lost in the control language, like if you add too many tests and so on. So it's hard to say, but I don't think developers tend to be able to understand the DCL fairly quickly. They're very scared of changing it, but they do understand.
Would you publish your code every month, or is that something that's secret sauce?
No, it's actually, well, I haven't published it for a while, but we do publish a slightly censored version every now and then.
Talk a little bit more about your CDN. The 5 data centers, right? And they're together via VPN. You announced 1AS.
Yeah.
Okay, so how do you deal with like peering? It seems like you said you peer with some folks with abilities in Europe. How do you deal with local peers like that when you that local numbers have a bad day?
Well, so we announced the same AS. We only peer at DKs right now.
I'm sorry, where?
DKs.
Okay.
But we announced different subnets of each location, and then we use DNS to send you to the closest node. So if that data center goes down, we'll start using IP numbers instead. That's how we deal with that. So it's theoretically possible that even if you pair with us, you end up in London if DNS servers means that that's closer.
So what's the advantage of announcing 1AS and backhaul?
Well, we announce different subnets from different locations. So we don't backhaul, we never backhaul the public requests. And the reason we got our NAS is because we needed multi-on and any cost.
Oh, I was actually asking like 1AS per site versus one.
Yeah. We haven't really run into problems, so we haven't really had to address that. Though we've been right, or people in Europe have pointed out to us that we should be using an AS number we get from Riak. Also, Aaron doesn't count our IP numbers in Europe as used. Assholes. Chris?
So you said you set link cost to latency. How variable is that latency, and how often do you change the
We don't, it's not that variable actually, and we don't automatically change it because we're too scared to do that. So we just monitor it and look, and then we change it. It's actually pretty unstable. I wish that our routers on the node that says multitude cost to latency, but they don't. Question here?
Arjun, do you have any sort of test framework for your VCL? Use like a rate or a way you can automate testing and do configuration changes?
I have a bunch of URLs I will copy and paste to per line to see if it does roughly the right thing. But it's been our to-do list to write proper test cases with VCL. And we just haven't gone around to it. I think when the next VCL related outage hits, we'll probably have enough energy to do it.
And you mentioned that you had some operations employees stateside and in Poland.
Yeah.
How do you coordinate between those?
IRC and video conferencing. And frequent travel. Any more?
Yeah, I didn't really get the X vary URL trick that you explained. If you could explain it again, because I didn't get it.
So basically, let's see if we can find this line. So basically, it's Varnish hashes on the hashing function you set. The hashing function we use is the hostname plus the URL. And then it will store all the variants of the object under that hashing set. So we abuse the variant method by adding an extra header that contains the real URL, canonicalize the URL into index.php type of equals, and then vary on that. So it's kind of like varying on accepting coding, or varying on, well, that's the only thing one vary on. And then when we send the request to the backend, we just copy the original URL into the request and send it off. So it's only to fool the hashing function. So we end up with all the versions of that object hashed into the same bucket, which is hostname plus index.php actually.
Yeah. Now I understand.
So some handler error.
You guys said you were really cost conscious. With regard to GeoIPs, if you're doing Maxmind, are you using the free products or are you actually paying for them?
We're actually paying for it, but we're paying for it because of, we basically get it for free because the ad sales team needed for things. It's also like $90 for an update. I think we update every 2 months. So.
Way back, many slides back, where you guys are using Google Analytics to capture the caseload time. What was it that you're getting on? I didn't see the code. Was it the all-mode event capturing the stop time and failover number? What keys do you track?
So this specific one, there is one that we do in on-mode as well. This specific one that I was using is inline in the HTML after all the text content has appeared, and after there are no more CSS files, so there are no more reflows. So the user can see the text, and the frame is fixed. But images could still be loading, and ads, this is actually specifically to measure before ads.
So in essence, this is perceived, kind of perceived download time, and that stuff gets tricky. What exactly? So is it perceived download?
This is the closest we've gotten to approximate perceived download time. We also measure on load, and we measure inside the networks, and we have, but the problem with those measurements for us is they're so variable because the ads, like some ad network sites, it takes 20 seconds to load. So now our alarms go off and we're like, oh, well, nothing we can do. So this is also the safest one that we found that we can monitor and act on.
So you have a piece, a specific piece in your page, and that's the piece.
Yeah. Yeah, if you go to the Wikia page and view source, you'll see it. I don't have the numbers yet, because I didn't configure the EGA correctly, but we're doing a test where we're like tagging which CDN node the user was hitting, so we can go and look geographically where people are actually, if they're getting the right CDN node or not. And then we're doing that by setting a cookie with the CDN node name, and then just calling GA on the client side. Okay, thank you.